This week we're going to learn how to solve quadratics in a couple different ways. In this video we're specifically going to go over how to solve quadratics by factoring. If a quadratic can be factored, then this is definitely the easiest and quickest way. There is another method which we'll learn in another video, but you definitely want to check first if a quadratic could be factored. Now, before we start going over how to actually solve quadratics by factoring, it's important to know that a solution to a quadratic is where the quadratic is equal to 0. This eventually is going to help us graph quadratics because this is going to tell us where the quadratic crosses the x-axis. When we graph a quadratic, it gives us a parabola shape, which a lot of you are familiar with, and normally when we think of a parabola, it crosses the x-axis twice. So this means in this first example, we would have two solutions because a solution is wherever it crosses the x-axis or wherever the quadratic is equal to 0. In the second example, even though I drew it terribly, this would actually have one solution. It's a terrible picture, but if you imagine that this is a better drawing, this would actually cross the x-axis one time. And then in this third example, it doesn't cross the x-axis at all. So for Algebra 1's sake, we're going to say it has no real solutions. Now, we have to say real because there actually are solutions. They are called imaginary. But we will not learn that in this class, and you will actually learn that in Algebra 2. So now, how do we actually find what those solutions are? To find those solutions, we're going to use something called the zero product property. The zero product property actually says something that you already know, but you probably just didn't know it as this property. It says if the product of two factors is 0, then at least one of the factors must be 0. This is kind of going off of the fact that anything times 0 is 0. It's something you already know, but we're going to use it in this section in order to solve by factoring. So let's start with an example to go over how the zero product property actually works. So we have this example that says solve, and it's actually already factored. So we have one factor, which is x minus 7, and one factor that is 2x plus 1. And it's already set equal to 0. So the zero product property says if we have two things being multiplied, which we do, this is already factored, and we have two things being multiplied and they're both set equal to 0, then one or the other factor must be equal to 0. So we're going to take each factor, x minus 7 equals 0, and then 2x plus 1 equals 0, and we're going to solve these. We're going to figure out when does each of those factors equal 0. Now, these are very simple one or two step equations that you can pretty much solve in your head, but I'll do it out just for this example. So we'd add 7 here, we get x equals 7, and over here we subtract 1, divide by 2, we get x equals negative 1/2. Now, if you don't believe me, we can check them. So we can take x equals 7, plug it in. So we'd have 7 minus 7, 2 times 7 plus 1. Does that equal 0? Right here, we have 0 times anything. It doesn't even matter what this is, equals 0. So yes, that one works. Same thing for the other solution. We have negative 1/2 minus 7. Again, it doesn't really matter what that equals because over here we'll have 2 times negative 1/2 plus 1. This, again, I don't care. This ends up being 0. Anything times 0 is 0, yes, so both solutions work. Like we went over in the beginning, most of these quadratics will have two solutions because of the shape of the parabola, but not always. You could get one and you could get no real solutions. We'll go over those later, but both of these are your solutions, x equals 7 and x equals negative 1/2, so you need them both. So now what happens if the quadratic is not factored, which is what we'll mostly deal with in this section. So first thing we need to do is factor it. We need to make it look just like the problem before. So this is a pretty easy factoring problem. If you did not do the factoring review, it's definitely a good idea to go back and try that before you do this section because you will have to factor in this section. So I have a quadratic where there's no number in front of the x squared, so a equals 1. So I'm just going to split this into my two sets of parentheses. I know the first two have to be x. I'm going to look at my signs. It's going to multiply to a positive, so I know these have to either be both positive or both negative, but because this middle term is a negative, I know they're both going to be negative. And now I'm trying to figure out what two numbers multiply to 12 and then add to negative 7. So it's going to be x minus 4, x minus 3 equals 0. So now we have a very easy problem here because the hardest part was the factoring. We have two factors set equal to 0, so I'm using my zero product property. X minus 4 equals 0 or x minus 3 equals 0. And those are very easy equations to solve. We get x equals 4, x equals 3. From here, all the steps are really the same for each problem. It's just a matter of can you factor the quadratics correctly. You're still going to follow the same steps. You're first going to factor, then you'll use the zero product properties to set each part equal to 0, and then you solve from there. So for this example, this is example 3. For this example, I have 9c squared minus 25 equals 0. I need to factor 9c squared minus 25. Now, there's another way you could do this. A lot of you will see that, but we're going to try to factor it instead for this problem. So I have two terms, and I know there's only a couple of ways that I can factor using two terms, and I notice that these are both perfect squares, so I'm thinking this is probably the difference of two squares. So what squared would give me 9c squared? It would be 3c, and then what squared gives me 25? It would be 5. So now, because I studied and I learned my formulas long time ago very well, I know that a squared minus b squared factors into a plus b, a minus b. So I'm going to factor 9c squared minus 25 into 3c plus 5 times 3c minus 5. And so now it's factored. I can use the zero product property, set each factor equal to 0. In this part, once you get going, you're going to start doing these in your head. Just be careful. We end up with c equals negative 5 over 3 and c equals positive 5 over 3. So I'm going to go over two more examples on how to solve by factoring that have like a little bit more difficult factoring steps involved, but if you think you have it, then you can probably leave this video because it's just going to be more examples. But if you need some more practice with factoring, if you need more examples, then I would definitely pay attention. I'm going to go over one that has an a term that is not 1, so that's probably the most difficult factoring. And then I'm going to go over one that has a GCF, so we can go over what happens with that. So this is the dreaded a does not equal 1 factoring problem. So I'm going to set up my parentheses. I know the first two terms, I know they're going to have x's. I know they have to multiply to 6. So how do we multiply to 6? We could have 1 and 6 or 2 and 3. We always want to start with the ones closer together, so I'm going to start with 3 and 2. Now over here, I need to multiply to a negative 7, so that's not too bad. Since 7 is prime, it could be positive 1, negative 7, or negative 1, positive 7. I'm just going to pick one. I'm going to try plus 1 minus 7. And to check it, remember we multiply the outsides, multiply the insides. 3x times negative 7 is negative 21. And then I have plus 2. Does that give me 11? Nope. So that is not the right combination. So I'm going to switch this. I'm going to get rid of that so I'm not confused. And I'm going to do well, I confused myself here. Because normally when I do these, I'll switch the order as well. So it could be 1, negative 7, but the 7 could also come first. So 7, negative 1, positive 7, negative 1. Oh my god, that's the same thing. I'm all screwed up now. Negative 7, positive 1. Alright, so let's try one of those. I'm going to try plus 7, minus 1. So it didn't work with the 1 first, and then the 7, so I'm going to switch the order. So on the outside, I have 3 times negative 1 is negative 3. 7 times 2 would be plus 14. Does that give me 11? Yes, so that is the right combination. So I have 3x plus 7 times 2x minus 1 equals 0. I'm going to take each factor, set them equal to 0. So 3x plus 7 equals 0. and then 2x minus 1 equals 0. So my solutions are x equals negative 7 over 3, x equals 1 over 2. So I lied to you. I'm going to do 2 more quick examples just so we can go over what happens when you have a GCF. There's 2 different scenarios. So in this problem, 4x squared minus 3x equals 0, you have to take out the GCF first, or else you're just going to mess yourself up. So they both have an x in common. So I'm going to factor out an x, and I'm left with 4x minus 3. Now, this looks easy, but what you want to be careful of, x is a factor, so you still need to set x equal to 0. And then we also need to set 4x minus 3 equal to 0. X equals 0, that's already solved. So you're all set with that part. The other solution would be 3 over 4. So you still have 2 solutions. You have x equals 0, x equals 3 over 4. Just be careful that you don't forget x equals 0. Now for the last problem, we're going to go over what happens when your GCF is a number. So in this example, we have 2x squared plus 12x plus 16 equals 0. We're going to factor out a 2. They all have a 2 in common. So I'm going to take out a 2. I'm left with x squared plus 6x plus 8. And then I'm going to factor what I have left. I'm going to factor x squared plus 6x plus 8. So what 2 numbers multiply to 8, add to 6? It would be x plus 4, x plus 2. We still have the 2 in the front. It would equal 0. Now, we still have to technically set every single factor equal to 0. So we have 2 equals 0, x plus 4 equals 0, and x plus 2 equals 0. Now, x2 equals 0, that doesn't even make sense. So that's not a solution. That is kind of just irrelevant. However, you still have to be careful about it because of that example that we just did. If the GCF has a variable in there, there will be a solution. So then our solutions in this one just end up being x equals negative 4, x equals negative 2. So that's about it for solving by factoring. Really, the most difficult part is the actual factoring. Once you can factor, your solutions should come easily as long as you use the zero product property.